Hi everyone. Let's talk about acoustics today. And our overall topic this week is interior partitions. Interior partitions fulfill multiple functions in your home. Right? The one we're talking about today is acoustic separation between spaces. You probably are very familiar with visual separation and access control. You would study those in like a space planning class, right? And these last three we're going to also discuss in this course. You've already looked at the structural support of bearing partitions. And we'll look at airflow when we study natural ventilation methods. And we'll look at the way that walls can contain utilities when we're talking about plumbing and electrical systems. But for now, let's talk about acoustics, starting with the concept of sound. What is sound? Right? It's a form of energy emitted by a source, so something produces the sound, and then travels through vibrations in the air until it reaches the receiver, which in this case is your ear. Okay? Sound is measured in decibels, and they're abbreviated with a lowercase d, uppercase b. And so those decibels can range all the way from a quiet bedroom in like the 20 decibel range, normal speech up to 50 and 60 decibels. We've got shouting up here at 80 decibels, and we've got a lawnmower up here closer to 100 decibels. As interior designers, we are concerned about these particular aspects of acoustics. It's sound transmission, impact noise, and reverberation. Sound transmission is the movement of sound from one space to another. Right? It affects privacy if somebody can overhear your speech, and it's controlled, by the construction of the interior partition between those two spaces. We measure sound transmission with the STC, and an important consideration is flanking sound. So if you've got a lovely acoustic partition, but you put a hole in it to put an electrical outlet and you forget to seal that hole, now you have flanking sound going right through that path. Right? Our next concern is impact noise, and that is noise from things like walking footfalls or dropping something heavy on the floor. All right. And it affects quiet enjoyment of space. And it's controlled mostly by the construction of the floor and ceiling between two different spaces. We measure impact noise by the impact insulation class. And the important thing to note is that impact noise travels through materials, right? So it's conducted by the structural materials of your floor and ceiling. Finally, reverberation. This is the bouncing of sound around space. So if you've ever had trouble with speech intelligibility in, for example, a crowded restaurant, you couldn't tell what your companions were saying, you probably had trouble with reverberation. This is controlled by the absorptive qualities of the finish materials in the spaces. This is the wall material, the upholstery, the curtains, all of that. All right. Yes, we can measure reverberation by the NRC. And an important consideration is that reverberation is when sound bounces off of surfaces. Of all of these different aspects of acoustics, the one we're going to focus on today and in this lecture is sound transmission. And so the STC is a rating of how well a partition attenuates or reduces airborne sound. So basically somebody is speaking on one side of a wall, how well can the person on the other side of the wall hear that? We use STC to rate partitions, ceilings, floors, doors, windows, etc. And it reflects a decibel reduction. So what are these STC ratings? Starting at super low, an STC of 25, someone on one side can clearly hear and understand somebody on the other side. A hollow core door is about an STC of 25. And that's if it's like fully fills the opening and doesn't have a big gap along the bottom. All right, STC of 25. And moving up to loud speech, you can hear it, but you can't tell what the words are. It's just like a murmur on the other side. That's somewhere in the 35 to 40 range, right? And this is going to be your typical wall with just 2 sheets of chipboard, one on either side, and nothing else. You can hear somebody talking on the other side. Usually you can't tell what it is they're saying. Right. Moving up to some excellent STC ratings, we've got in the 45 and 50. If there's a loud sound, yeah, you can hear it faintly, but just a little bit. Right. Now let's look at some requirements and recommendations for STC ratings. Starting with California Building Code, Cal Green only addresses STC ratings in one place, and that is with multifamily residential. When you've got different tenant spaces, you need to separate them with an STC of at least 40. And remember, that's loud speech. You can hear it, but you can't tell what they're saying. Okay. But here, this class is about kitchen and bath design, and so we're interested in the NKBA guidelines. These are recommendations and not requirements, right? They're not code. But the recommendation is to provide STC 45 to 52 between kitchens, laundries, and baths, and other living spaces. We just don't want to hear what happens in the bathroom when you're in the living room, all right? Where does that fall upon our STC rating list? It's way up here, all right? 45 to 52. So you can hear if somebody's speaking loudly, but you can't tell what they're saying. It's just barely there. Okay. What kind of variables can affect this sound transmission through a wall? There are 6 of them here. Let's start up here with the mass. This is how heavy the wall is, and a heavy partition will transmit less sound than a light one. So looking over here at the diagram, we've got a source of sound, and then if this partition is heavier, it will vibrate less, and less sound is transmitted through it. Our next one is cavity absorption. And the idea here is that we add insulation in that wall cavity. It will absorb some of the sound, less will be transmitted. And so that would go right in here in the middle of the wall cavity. Our next one is cavity depth. If we make our wall deeper or thicker, you can hold more cavity insulation, and you can lower your STC rating. Whoops, I said that wrong. You can raise your STC rating. Our next variable is stiffness. This is probably the hardest to understand, and it's the most challenging to control. You can't really control this, but it turns out that if your wall is a little bit softer, a little bit less stiff, it will transmit less sound than one that is very rigid. Right? And you can think about this as like the surface of a drum head. If you've ever played a drum, you know that drum head is super tight and stiff. Whereas if you think of it a little bit looser, you're not going to be able to make the same sound with it. All right, the next 2 are really important. They are the ones that work the best for raising that STC rating and reducing the amount of sound transmission. The first one is decoupling. All right, what this means is kind of physically separating our wall components to slow down or eliminate some transmission of sound. And what that means, looking at our diagram over here again, if we've got noise happening on this side, all right, that movement, right, the movement of particles is going to vibrate this surface of the wall. If we can decouple these two surfaces so that they don't vibrate together, so that one vibrates and the other is able to remain still, then we will get less noise transmission, right? It's called decoupling. Finally, damping. Damping is when you dissipate those sound waves with some specific elastic-based materials that are found within sound dampening gypsum board. All right, we've been talking about these STC ratings, and they are for an entire wall assembly, not for just one individual component. Like you wouldn't add up like all the STC ratings of the wood and the gypsum board. No, it doesn't work that way. It's for the entire wall assembly. So let's look at some of these, and I also want you to go to this reference and make sure you take a look and understand all of these different wall assemblies. Let's start with this one right here. This is your absolutely standard interior partition. It's got 2x4 wood studs with, in this case, it's 5/8 inch gypsum board on either side. Don't get confused because it says fire shield. Acoustically, they don't perform any differently than the standard, okay? And this wall is STC 35. Coming over to, and I put our little reference over here, coming over to our rating here, STC 35 means that speech is audible on the other side, but it's not intelligible. You can't quite tell what somebody's saying. Right? This is our baseline. Moving to our next wall assembly, the first thing anybody thinks about is, oh, let's add that cavity insulation, right? Great idea. It will help, but not very much. All right. So this is the exact same wall assembly. We've now added fiberglass batt insulation, and we went up from 35 to 36. Okay. Notice that that's not enough to be very useful. Let's try that again. Notice this, it does not reach our NKBA recommendations, and it's a very small increase. In fact, you have to have an increase of 2 or 3 decibels in your STC rating to even notice the difference, all right, for the human ear to notice a difference. Now, you can improve this a little bit. They didn't have it in this particular reference book, but you can use mineral wool. You might have heard this called rock wool insulation. It's slightly heavier and performs better acoustically, and you'll get another point or 2. All right. Moving on, let's take a look at what happens when you start using the specialty acoustic gypsum board. All right, and on the left, we have our same standard 2x4 wall. We've got standard gypsum board on one side, we've got the fiberglass batt insulation, and we've got the acoustic gypboard on the other side. All right, immediately you notice that there's a fairly large jump up to an STC 42. All right, notice this is close but not quite at that NKBA recommendation. Honestly, the human ear can't really tell the difference between 42 and 45, so you're probably good on this one. Also, take a look at the different products. We're looking at a specific brand and a specific product. So if you want something else, you can also specify a different brand, which might perform a little differently. Moving to, now we're putting acoustic gypsum board on both sides of a wall, and we jump up from 42 to 45. Finally, we are in that NKBA recommended area for the wall between, for example, a bathroom and a bedroom, or a bathroom and a living room. All right, let's take a look at one last example, and this one is using resilient channel. Resilient channel is this metal piece we're looking at right here, and you can see somebody installing it right here. And this is an example of decoupling. What the resilient channel does is allow one side of the wall to vibrate, right? It's a little bit flexible. One side of the wall to vibrate and the other side to remain still. Notice we're not using any of the specialty acoustic gypsum board in this case, but we have jumped all the way up to STC of 51. This is a very good acoustic wall for residences. The problem is the resilient channel is fairly hard to install. And if your contractor installs it incorrectly, it ruins the acoustic benefits. If they send the screw all the way through the channel instead of just one piece of it, you no longer get that decoupling piece. Thanks everyone. In this video, we just had an overview of acoustics for kitchen and bath, specifically looking at sound transmission through our walls.